Permutations and combinations. Our objective: solve counting problems using permutations and combinations. Let's start with permutations. What is a permutation? It is a counting technique where the order in which the objects are chosen matters. Order matters. What you want to be thinking is permutation deals with things that need to be in a particular position. Okay, they need to be ordered. So permutation, position. And here's what it's all about. Number of permutations of n distinct objects taken, R at a time. The number of arrangements, the number of possibilities of R objects chosen from n objects in which 1, the n objects are distinct, 2, repetition is not allowed, and 3, the order is important. Notice I highlighted that in italic here. Given by the formula, NPR, sounds like the National Public Radio, right? So sub n p sub r is equal to n factorial divided by n minus r factorial. And we talked about factorial in a previous video. Okay, let's take a look at a couple of examples here. All right, again, order matters. Okay, and we're not repeating. So once you're chosen, you're chosen. Example 1 we did in a previous video, and we'll see the same thing happen here. We'll solve it this time using this formula, the permutations formula. 3 members from a 14-member committee are to be randomly selected to serve as chair, vice chair, and secretary. The first person selected is the chairperson, the second is the vice chair, the third is the secretary. How many different committee structures are possible? Obviously, order matters. If you're chosen first, you're going to be the chair. The order matters, okay? So, n objects. So we have the P, okay, and we have chosen from n objects. We have 14 people. We're choosing from 14, so that's our n. This is our n, and we're choosing, how many? We're choosing 3. The number of R objects chosen from n objects. So this is our R3. So this is what we're looking for right here. We're choosing 3 objects from 14 objects. So the first number is the total number of objects. The second object in this case is how many we're choosing. Okay, let's just use our formula. N factorial, n is 14. So 14 factorial divided by n minus r factorial. So 14 minus 3 factorial. That goes into a calculator. And we come up with, 2,184 different committee structures are possible. The same answer we got in a previous video. All right, a second example. The Indy 500. Suppose we got 40 cars starting the Indianapolis 500. In how many ways can the top 3 cars finish the race? Does order matter? Yes, because if you're chosen first, you're the first place finisher. So the order matters here. The order is important. So we're talking about a permutation. The order matters. If you're chosen, finishing first means you don't finish second or third. Okay, the top 3 cars, a first place finisher is not going to be a second place finisher or a third place finisher. The order makes a difference. We got 40 total cars. So this is our N. And we want to choose from those 40, 3 cars. So this is our R. So 40P3. Okay, let's apply our formula right up there. It's going to be 40 factorial divided by 40 minus 3 factorial, which of course is 37 factorial. 40 factorial divided by 37 factorial is 59,280 possibilities. Okay, it's possible ways that the top 3 cars can finish in the race. Okay. Okay. Now let's take a look at, whoops, I gotta get a new paper out. Sorry about that. Let's take a look at what are combinations. In a permutation, the order matters. In a combination, the order doesn't matter. We're just choosing a group. And it doesn't matter if you were chosen first, second, or third. You're still in the group. You're part of the group no matter when you were chosen. So combination, a counting technique where the order in which the objects are chosen does not matter. Okay, we're just choosing people to be in the group. For example, the number of combinations of n distinct objects taken r at a time. The number of arrangements or possibilities of r objects chosen from n objects in which the n objects are distinct, repetition is not allowed, you don't get to be picked twice, and order doesn't matter. Okay, again, back to that idea of I'm picking people to serve on a committee. All right, I'm going to pick 4 people to serve on a committee. Whether you're picked first, second, third, or fourth does not matter. You're on the committee. It doesn't matter if you got picked first. We're picking a committee of 4 that are going to be committee members, and who cares who gets picked first, second, or third. So the order is not important. That's the difference between combinations and permutations. And you'll have this formula to use. The C formula, the combinations formula, says the number of objects, the total number of objects factorial divided by the how many you want factorial times the total minus how many you want the difference factorial. And as you might imagine, this will again help with an example. So let's take a look. Let's keep that formula right there for us. Roger, Ken, Tom, and Jay are going to play golf. They randomly select teams of 2 players each. List all possible team combinations, or how many possible team combinations are there? Let's list them, then let's use this to do it. List all possible team combinations. Okay, we'll do a sample space. Well, Roger could be with Ken. That's one possibility. Roger could be with Tom. Roger could be with Jay. Now, notice I don't have to also list Ken could be with Roger, because once Roger and Ken are together, it doesn't matter whose initial is first. Roger and Ken is the same thing as Ken and Roger. So the order doesn't matter. Okay, so this is equal to Ken, Roger. Order makes no difference. They're on a team together, whether or not they're listed Roger, Ken, or Ken, Roger, they're on the same team. Continuing, Roger's been used 3 times. Ken now, again, I'm not going to list Ken, Roger, because he's already here. But Ken can be listed with Tom, or Ken can be listed with Jay. And finally, Tom and Jay could be a team. So we know the answer is 6, okay? Again, highlighting, focusing on, stressing that the team of Ken Tom is the same as the team of Tom Ken. Same. So the order doesn't matter. Let's use our formula. Okay, it's a C formula, combinations formula. We're choosing from 6 people, and we're choosing groups of 2. So N is 6. Excuse me. Wait. I'm sorry about that. We're choosing from 4 people. There are 4 people. Look at me getting this incorrect. There are 4 people. So this is our N. And we're selecting teams of 2. That's our R. 4 total people. We want groups of 2. And we don't care what order they're in. They're going to be on the same team. So N factorial is 4 factorial. Over R factorial, which is 2 factorial, times N minus R, which is 4 minus 2, and that difference factorial. That goes into a calculator, and that comes out with what we already know. 1, 2, 3, 4, 5, 6. There are 6 possible team combinations. Okay, we'll do a second example of that one. that we can't as easily create a sample space for. How many different simple random samples of size 4 can be obtained from a population of 20? Okay, so we want to take 4 samples. We want to choose 4 samples, and that will be, we want to choose sample sizes of 4 from these 20. Okay, it doesn't matter when we choose them. Once you're chosen, you're in the sample. If you're the first person, the first item chosen, or the 4th item chosen, no one cares. The 4 are chosen are in the sample. The fact you're chosen first doesn't make any difference. You're still in the sample. Okay, so this is a combinations problem. We have a population of size 20. This is our N. And we want samples of size 4. This is our R. Okay, so we're going to use the combination. N is 20. We're choosing groups of 4. And you're in the group. Whether you're chosen first, second, third, or fourth makes no difference. You're in the group. Who cares when you were chosen? You're in the group. Okay, we'll go back and use our formula. Can I get it on the same page? Probably not. So I'll just kind of speak to it as I write. N factorial means that the numerator is 20 factorial divided by R factorial, which is 4 factorial times N minus R. Yes, N minus R factorial. And there are 4,845 different samples of size 4 that can be obtained from a population that has 20 items in it. Okay, there you go. So there you have it, combinations and permutations. Combination position. Position matters. Excuse me, permutation, look at me, listen to me getting confused. Permutation, position. The order matters, the position you're chosen matters. Combination, order does not matter. Nobody cares. You're on the team.